Alright, you're given a general position function, but we would like to write one that is specific for a scenario where an object will be thrown from the top of a 600-foot building at an initial velocity of negative 30 feet per second, negative since the object is going down, and your job is to begin by writing the position function. Okay. Well, we will plug 600 in for the initial position, the height, and we'll plug negative 30 in for the initial velocity. Then your position function becomes negative 16t squared minus 30t plus 600. Okay. Well, we'll also write a velocity function. To do that, you need to differentiate. We take the first derivative. The derivative of negative 16t squared, this will be your velocity function, is negative 32t. The derivative of negative 30t is just negative 30. Okay, well there's our velocity function. We could say it again. Oh, it's right there. The next thing that we're going to do is find the average velocity on the interval of time from 1 to 3. As for that average velocity, our formula is the change in position, like the change in y, over the change in time, like the change in x. In order to be able to use this formula, I need to know what is s of 3. That is, I've got to plug it into our original position function, which said negative 16 times whatever that time is squared minus 30 times that time plus 600. If we follow the proper order of operations and work this out, we end up with a position of 366 feet. Let's hold on to that. S of 1, plug it in again. Negative 16 times 1 squared minus 30 times 1 plus 600. If we work that out correctly, we get a position of 554 feet. This we can plug in. So we've got 366, take away 554, divided by 3, take away 1. That's negative 188 divided by 2, which is negative 94 feet per second for our average velocity. What's another question? What is the instantaneous velocity when time is 1? We would plug into our first derivative the velocity function, which says negative 32 times whatever is the time, take away 30, that is negative 62 feet per second at time is 1 second. As for the initial velocity at time is 3 seconds, same thing. Plug it into your first derivative. In other words, plug it into your velocity function. That's negative 32 times 3, take away 30, negative 96, take away 30, it's negative 126 feet per second at time is 3 seconds. Another question, how long does it take to reach the ground? Well, at the ground, the position, s of t, is 0. So we set that position function equal to 0, just like you did in algebra. Now, this is not factorable. We can use the quadratic formula with these numbers, negative 16, negative 30, and positive 600, or we could use the quadratic formula after factoring out a negative and a GCF of 2. All signs would change. Negative 16 divided by negative 2 is 8. Negative 30 divided by negative 2 is 15. 600 divided by negative 2 is negative 300. We'll plug into that quadratic formula where A is going to be 8, B is 15, and C negative 300. So that is the opposite of B, plus or minus the square root. Excuse me, that's wrong. The opposite of B, the opposite of 15, plus or minus the square root, B squared, that's 15 squared minus 4 times A times C, and it's all over 2 times A. That 15 squared gives us 225. A negative times a positive times a negative will turn out positive. 4 times 8 times 300 is 9,600. This is all over 16. That gives us plus or minus 9,825. It's all over 16. This is approximately negative 15 plus or minus 99 and a little, all divided by 16. When we simplify this, we end up with two answers, only one of which is believable, 5.26 seconds or negative 7.13 seconds. We're going to throw away negative time. So the time it takes to reach the ground is about 5.26 seconds. One final question. What is that velocity at that time when the object does reach the ground? To answer that question, you plug your answer of 5.26 seconds into your first derivative. In other words, you plug it into your velocity function. And that velocity function is defined to be negative 32 times whatever you're plugging in for t. Take away 30. When we work this out, we get about 198 and 32 hundredths feet per second. Of course, it's negative because we're talking about an object going down. Okay, that's it.